think I should start now. It's 8 o'clock. Okay, so let's start. So today I'm going to start as a new chapter, analog transmission. So before I start this chapter, I just wanna link things together. So as I told you before, we have a band bass, and also we have broad. I told you before we have one band bass and we have broadband. Okay, so in order to link things together, I wanna make a very quick revision on them. So let's start with the band bass. So I told you before, in the case of band bass, what happens here is we have a link between sender and receiver. And what we do here, number one, we transmit. If you have binary, always we talk about binary data. So actually here you transmit digital signals, okay? And that's what we did in the last chapter. Last chapter we explained if you have digital data, how can you convert the digital data to digital? Take a seat, please. When I finish the lecture, after the lecture, you don't make disruption. Take a seat. Okay. So last section I explained if you have digital data, how can you convert it to digital signal and then transmit digital signals? Okay. That's what we did in the last chapter. Also, I told you this channel has low bass effect. Okay, low bass effect. And also, and this is the most important thing, I told you also only one can transmit. Okay, so you actually use the whole channel. You got what I'm saying? So it's not allowed to have multiple transmissions here because you are going to use the whole bandwidth. Okay, and I told you the reason here I have to use the whole bandwidth because I told you if you have like a square wave like this one actually has infinite. It has too many frequencies. Okay, so if I give you a small amount of frequencies, you cannot transmit this one. Very simple. Okay, so that's why here I have to use the whole bandwidth here. Okay, and I told you, by the way, both of them are used. Okay, both of them are used, but in different scenarios. For example, as you will see later, this one actually is used in case of if you have a bus in a lane. Okay, if you have a bus and you have several computers connected this way, so only one computer can transmit at a time. So we can use this one. Okay.
Also, star topology.
Yes, in star topology, or when there is one link between transmitter and receiver, one link. Okay, so yes. That's what I have explained before. Now let's move to broadband transmission. Okay, in broadband transmission, number one, we're gonna transmit. You have to convert our binary data to analog, and we don't have other choice. I'm gonna tell you why you have to convert to analog. Simply because in case of broadband, I'm not gonna give you the whole bandwidth. Okay, I'm not going to give you the whole bandwidth of the channel. Instead, I'm going to give you a small bandwidth. That's why what you can see here, this is the whole bandwidth. We have different bands. So here, this is a band, another band, another band. So F1, F2, F3, F4, whatever. Okay. So all you have to do the transmission in your band. You got what I'm saying? So that's why here we can do multiple transmissions at the same time. Because everyone is gonna transmit in its band, in band بتاعه, okay, in its band. So that's why you can have one transmission here, you can transmission here, you have to transmission here, and so on. Is that okay? So the question is that if I have data, how I can make sure my data is gonna be in this band, or your data is gonna be in this band, or your data is gonna be in this band? How I can make sure of that? Okay, by using what we call carrier frequency. So the carrier frequency is actually frequency in the middle here. Okay, you will see right now, that's what I'm going to explain today. So here we are going to transmit analog signals, and these analog signals are carrying the binary data, okay? And because of using as a carrier signal, I can make sure my data is here or here or here or here. So every one of them has different carrier. Carrier is the frequency in the middle here, okay, as you can see. Okay. I told you this one is used also. It's like in case of in the air, you can do Bluetooth, right? And you can transmit Wi-Fi and also 4G or 5G. How can we do all these transmissions together? We can do it simply because every one of them using different band, different frequency band. Is that okay? One more thing, and this what is going to be one of the important topics in this course is actually collision. You know what is collision, right? So you told me before you know collision. Okay. Actually, here we have collision here in case of bandpass because only one should use the channel. That's what I said, right? So if two computers use the channel at the same time, using the same frequencies, that's what we call collision. Okay, so actually we corrupt the signals. Okay, however, here this is not collision. Here is not collision because yes, we're going to transmit at the same time, but different frequencies. So we don't have a problem. Big difference if it's the same. If two transmit in the same band, yes, we have collision. You understand what I'm saying? So anyway, so this chapter is about analog transmission. So all this chapter is gonna talk about number one. How can you convert the binary data to analog signal? And keep in mind, this analog signal is carrying the binary data. Okay, this is number one. Number two, how I make sure everyone is going to be in the band. It's band. Okay. ما هو يعني تقولي دي بتستعمل one يعني ده بيكون في one transmission ده في multiple transmission. So based on your understanding, you can come up with multiple several differences. Okay, so now I'm gonna start with here. That's what we call digital to analog conversion. Remember, in the last chapter, this chapter is called analog transmission. Okay, last chapter was digital transmission, and in the last chapter, you remember this was digital because we need to convert the digital data. We need to convert the digital data into digital signal. This time we are going to convert the digital data into analog signal. Okay, and to do that, we have different approaches we are going to discuss. First of all, I'm going to talk about like introduction about it. Then I'm going to talk about amplitude shift keying, frequency, phase shift keying, and so on. So we're going to discuss different approaches. Okay. So I think that's what I explained. So here we use analog transmission in case of bandpass. You don't have other option. If you have a bandpass, if you have a certain bandwidth, you cannot transmit digital. You don't have any other option here, okay? Other than doing modulation and demodulation. Modulation means converting the binary data to analog, okay? Digital to analog conversion is converting the digital to a pass analog, a bandpass analog. Okay, and so now what we are going to do here. Okay, so first of all, as I told you, we have different bands. Okay, we have different bands this way. I have to make sure I have to make sure the analog again. What I'm going to do right now, I'm going to convert the binary signal to analog. However, is that everything? No, it's not everything. I have to make sure the analog I converted is going to be in this band or in this band or in this band. Is that okay? How I can make sure of that? As I told you, we're going to have here what we call carrier frequency. We're going to have here carrier frequency. So I have to use, that's what you're going to see right now. I'm going to use what we call carrier frequency, okay? A carrier frequency is a frequency that's in the middle of your band, and is actually a sine wave. So this is a sine wave. I have to make sure it's in the middle of this one, and then I have to modify. So this one is going to carry the binary data. So I have to modify the carrier frequency based on the binary data, if it is 1 or 0, okay? And when you do this modification, I'm going to now teach, teach 3 different approaches, okay? You know, for any sine wave, okay, you have amplitude, you have phase, you have frequency. These are the 3 main characteristics of any sine wave, okay? So in one approach, we are gonna, again, we agree what we're gonna do. We agree we're gonna use carrier frequency, okay? Which is frequency in the middle of the band. And then I'm gonna modify it based on your data, 0 or 1. When I do that, I'm gonna guarantee I'm the middle of, I'm gonna be in my band, okay? But what do you mean by modify? When I mean by modify, one of 3 things. Number 1, I can modify the amplitude, okay? So maybe 0 is going to have a certain amplitude. 1 is going to have a different amplitude. Very simple, right? I can modify the phase. So 0 is going to have a certain phase. 1 is going to have a different phase. I can modify the frequency. So 0 is going to have a certain frequency. 1 is going to have a different frequency. And as a receiver, so now I'm going to modify one of them, and one approach is going to modify 2. So you will see right now, okay? As a receiver, for example, let me make it easy. For example, if I'm going to modify the amplitude, as you will see right now, for example, I'm going to, for 1, I'm going to send this is for 1. For 0, I'm going to send 0. Or I'm going to send something with a different amplitude, okay? The amplitude has to be different. That's it. So 1 amplitude for 1, for example, 1 amplitude for 0. When the receiver receives the signal, the receiver has to see if this is this amplitude or this amplitude. Okay. The same thing for the phase. For example, I'm gonna use, you know, this is phase 0. As I explained to you before, this is the phase of this one is 0. If in case of phase 180, for example, is going to be something, it doesn't need to be 180, okay? It's going to be something like that. Can be any other phase, okay? So for 1, I'm going to transmit this one. For 0, I'm going to multiply this one. This is the carrier frequency. I'm going to multiply, okay? At the receiver side, when I receive this one, I'm going to understand you are sending 0. When you send this one, I'm going to understand you are sending 1, and so on. Same thing for frequency, okay? So as you will see right now, we're going to have 2 frequencies, only because we're binary, 0 or 1, right? 2 frequencies. So we're going to have, like, for example, a small frequency, and then we're going to have like another frequency here, okay? So, for example, every time I have 1, I'm going to use this one, 0. So this is for 1, this is for 0. So the receiver has to keep track of the frequency. You got what I'm saying? If I receive this frequency, 0, frequency is 1. Okay. Now I'm going to go to the details. So this is a big picture. So again, I want to summarize the main points here. Number 1. Okay. We have different bands. This is number 1. Okay. Number 2, you have to make sure when you transmit 0 or 1s, you have to keep your signal. The signal you are going to transmit, you have to make sure the frequency component, the frequency domain of this signal is here, or here, or here, or here. Is that okay? This is an important point. How I can make sure? Okay, this is easy. Listen to me. If I want to transmit in this band, so I have the frequency in the middle. I'm going to call it carrier frequency. I'm going to modify this frequency. I'm going to modify this signal. When you modify the signal, you are going to hear. Okay. If I don't transmit the data here, so I'm gonna use a different carrier frequency. So I'm gonna work here. Once you work with this frequency here and you modify it, you will be here, or you'll be here. That's why you can transmit at the same time. You have your own carrier frequency. I have my own carrier frequency. Everybody has different carrier frequency. Okay, and we have to make sure I will be here, you will be here, you will be here. That's why you can transmit at the same time, and there is no collision, right? But at the receiver, how the receiver can what you usually, filters, right? I don't know, in electronics you took filters. So at the receiver, if I make a filter here, if I make a filter if I make a filter here, so actually I'm going to receive this signal, right, from this person, because we have multiple transmission right now. This one transmission, one transmission, one transmission, one transmission, and so on. So if I want to receive this transmission, I'm going to make the filter here. If I make the filter here, I'm going to receive this one. If I make the filter here, I'm going to receive this one, and so on. Is that okay? That's actually when you use the radio and you change the station, you're changing the filter, you're changing the capacitor or some component of the filter. By doing that, you move the filter from here to here. Okay, if you have a filter, so the filter is gonna only pass a certain frequencies, is gonna block the other frequencies. Any questions? Okay. What is that? ممكن يعني ممكن يكون الفلترنج مش تم بطريقه كويسه اكسبت تو ستيشنز مع بعض، ممكن. خدت بالك؟ So here, so in analog transmission, the sending device is going to produce a high frequency signal that acts as the base of the information, and this one, as actually we call it the carrier frequency. Okay, so receiving has to be tuned to this carrier frequency. Okay, so if you want to in radio, if you want to receive a certain station, you have to tune the filter to the carrier frequency of this one. Okay. So yeah, for example, yeah. So this is actually exactly what I'm going to explain right now. So given digital data, we are going to do here modulation. We are going to do here demodulation. Oh, and that's exactly what we did last time. It was encoding decoder. Okay, and actually I explained only one because the other one is exactly the same thing but in the opposite, right? What do you mean by opposite? So here you are going to convert the binary data to analog. This one is going to do the opposite. It's going to convert this analog signal to digital data. That's why we call it modulation, demodulation, encoder or decoder. Okay. Anyway, so this is what I'm going to start to explain. I'm going to start with amplitude shift keying, frequency shift keying, and phase shift keying. Okay. And at least for now, you know the difference. In these three cases, I have carrier frequency, but here I'm going to modify the amplitude. So 0 is going to have a different amplitude than 1. But here, frequency, 0 is going to have frequency, 1 is going to have a certain frequency. And I'm not going to change the other two. So I have 3 things. I can change one of the 3 things. Amplitude, frequency, phase. So here, I'm going to change the amplitude, but I'm not going to change the frequency. I'm not going to change phase. Here, I'm going to change the frequency, but I'm not going to change amplitude. I'm not going to change phase. Here, I'm going to change phase, but I'm not going to change amplitude. I'm not going to change frequency. And then you will see later, it may be a better idea if you combine these two together in one scheme. So I'm going to teach you 4 schemes here. Let's start with the first one, amplitude shift keying. So as I told you, very simple. In amplitude shift keying, number 1, we have a carrier frequency. That's number 1. Okay, we are going to modify the carrier frequency, and then I need 2 amplitudes, 1 for 0, 1 for 1. Very simple. Okay, so the very simple way is, as you see here, I'm going to use this is the carrier frequency. I'm going to use it for 1, and then for 0, I'm going to use 0. Okay, so 0 here is it's like the carrier frequency with 0 amplitude, like a sine wave with 0 amplitude. Okay, so anyway, so here, I have here 2 different amplitudes, 1 for 1, 1 for 0, 1 for 1, 1 for 0. So every time I want, as you see here, every time I want to transmit 1, I'm gonna transmit this one. This is a signal element. You remember signal element I explained to you before? Yeah. So this is the signal element. Every signal element is gonna carry, similar to what I told before, every signal element is going to carry only 1 bit. So if I ask you what is R is 1. Similar to what I did before, okay? R is 1 because R here actually number of bits divided by the number of signal element, okay? Here we have 1 signal element, here I'm going to, so every time I transmit 0, it's going to be this one. Every time I transmit 1, it's going to be the carrier frequency is this way, okay? So this is what we call binary amplitude shift keying. Okay, binary because you are going to transmit only 0 or 1. You know, now I'm going to talk about multiple levels. Still, you can do multiple levels as well. Okay, multiple levels mean in every signal here, in every signal element, maybe I'm going to transmit 2 bits. So I'm going to transmit here 0, 0 or 1, 1 or whatever, as you will see later. But now, that's when I tell you this is binary amplitude shift keying. Binary here means it's only, you're going to transmit only 1 bit at a time. Okay, so we don't have, it's not multi-level as I explained before. By the way, so this one we call it binary amplitude shift keying, or sometimes we call it on-off keying. Okay, and you can tell from the English name on off because this is on and this is off. Okay, so first of all, how can we implement, what kind of circuit I can use to implement this idea? So as you see here, number one, I need what we call oscillator. I'm not sure if you have ever heard about oscillator. Oscillator is electronic circuit. Okay, we use capacitors, we use crystal. Okay, some electronic component. And this electronic circuit is gonna generate a sine wave with a selected frequency. So you have to select the component of the circuit to generate a frequency signal sine wave with a certain frequency. Okay, that's what we call oscillator. Okay. Also, we have here what we call electronic circuit. We call it multiplier. So multiplier, you can tell from the English name. Multiplier, it has 2 inputs. It's going to multiply these 2 inputs together, and then the output, you are going to get the output here. So I want to tell you here, if you have what I'm going to do here, I'm going to use non-return to 0 signal in the binary. At the binary side, I'm going to use non-return to 0. So in case of 1 is going to be a positive voltage, 0 is going to be 0. 1 is going to be a positive voltage, and 0. Is that okay? So, and then I'm gonna, so this is one input to the multiplier. The other input is the carrier. The other input is the carrier. When you do multiplication, what is the output when you do multiplication? Okay, you can tell here, when I multiply 1 by the carrier, I'm gonna get the carrier, right? When I multiply 0 by the carrier, I'm gonna get 0. Multiply 1, I'm gonna get the same. I'm gonna get the same signal. Okay, for sure. If one here, for example, 5 volt, you are gonna get the same signal but amplified. Okay, because you multiply by 5, amplified. Any questions? Can you listen here, please? Stop talking. You can talk after the lecture. You have 24 hours after the lecture. You can talk. Okay. Anyway, okay, you understand what I'm saying? So you just do multiplication. So here, this is my binary signals. It can be positive and 0, positive and 0. So if you do just multiplication, okay, and this is a signal. Don't be confused here, because yes, I have digital signal, but this is not what I'm gonna send. What I'm gonna send in the channel, this signal. This is the signal I'm gonna send in the channel. You got what I'm saying? Yeah. By this way, I converted the binary data to analog signal, and this is what I'm going to transmit in the channel. This is different from what we did in the last chapter. In the last chapter, we actually transmitted this signal. Any questions? Okay. So now you can tell why it's called on-off. Okay, because you actually on here. This is on off. Okay. Anyway, so now let's talk about what is the bandwidth, similar to what we did before, similar to what we did in the last chapter. I need to know what is the bandwidth needed for this case. Is that okay? Okay, this is actually, if you convert, if you look for the frequency domain of this signal, this should be the frequency domain of this signal. Okay. There is something here may be confusing for you. Listen to me. I told you before, if you have a signal, if you have a simple signal like this one, what is the frequency domain of this one? Yes, it's only 1. The frequency domain is going to be only 1. Whatever, for example, if this is 1 kHz, so at 1 kHz here, it's going to be only 1. Okay. However, because of this part here, this signal is not simple anymore. You got what I'm saying? So because what you have, so if you don't have these parts here, I should here have only 1, right? Because it's only 1 frequency. However, because what I did here, so here I converted the analog signal. Now the signal became the signal became non-periodic composite signal. It became like a composite signal. That's why the signal has a range of frequency, as you see here. Okay, and because it's non-periodic, this was a question in the quiz, because it's non-periodic, the frequency is continuous, as you see here, it's continuous. Okay, so again, what you can see here, by modifying the carrier frequency, I'm gonna get several frequencies around the carrier frequency. So now the question is, what is the bandwidth? In order to transmit this one, how much bandwidth do you need? Is that okay? And this is the bandwidth. For sure, as I said before multiple times, the minimum, the bandwidth is going to be the better for sure. Okay. So here in this case, the bandwidth is equal to 1 plus D, okay, times S. D is constant. It's a constant between 0 and 1. So D is the value between 0 and 1. It's a constant value. It's going to be given to you. And this constant value actually depends on the modulation process. Also, it depends on the, so here's the modulation process and the filtering process, because you have to do filtering, quality of the filtering, whatever. Okay, it's a value between, it's constant value between 0 and 1. And S here is actually N times 1 over R. Okay, S is the signal rate. How many measured? Maybe this part little bit confusing to you, because we have here 3 units that are very close to each other. Bit rate, bits per second. The baud rate, how many signal elements per second? Okay, and also number 3, hertz. So you have three units that are very close to each other. Bit rate, which is N. This is how many bit per second. Okay, here bit rate is 5. We have baud rate. Baud rate means how many signal element, 5 signal element in 1 second, and also we have hertz. Okay, I think I have an example to clarify again to clarify the difference between them. Okay, so here, as you see here, so B, the bandwidth should equal 1 plus D times S is N times 1 over R. Okay, here R is 1. We're gonna calculate R in the same way we calculated before. R is here is gonna be one bit for every one signal, so it's gonna be 1 over 1, which is 1. Okay, so by this way, actually B, as I'm explaining here, B should equal the bandwidth 1 plus D times N. Is that okay? N is the bit rate. So now I told you D is a constant value. It can be between 0 or 1. So in case, so that means what is the minimum bandwidth I can get here? The minimum when D is equal to 0, right? So when this D is equal to 0, I'm gonna get the minimum value. It is actually B is equal to N. So the minimum B is equal to S, and S is actually equal to N, because N times 1 over R is 1. Okay. For maximum, D here is gonna equal to 1, because D is 0, between 0 and 1. So in this case, it's gonna be 2N. So always the bandwidth needed for me between N and 2N. Between N and 2N. Yes, what's your question? Okay. Any questions? Okay. So always, that's what you, always the middle of the bandwidth is actually the carrier frequency. Okay. So if I give you any bandwidth in the middle here, it's the carrier frequency. Okay. I think I have example here. I have example before I give you other stuff. So the example here we have, I'm telling you here in this example, we have an available bandwidth of 100 kilohertz. Okay, so the bandwidth is 100 kilohertz. So from here to here is actually 100 kilohertz. Okay, and then I'm telling you this 100 kilohertz is actually starting from 200 to 300, 100K. Okay, This is your band. You have to make sure you transmit in this band. Just use, okay? So now if I ask you, what is the carrier frequency? If I give you a question like this in quiz, okay? Or in the, for sure, I think this won't be in the quiz anymore, but it will be in the final, in the midterm. But anyway, so if you have a question like this one, can you get the carrier frequency? Yes, the carrier frequency always in the middle, always in the middle. So you have to see what is the middle value here, okay? So because this one is 100, so actually from here to here is 50, and from here to here is 50, okay? Because I'm telling you the bandwidth from here to here is 100, and this is carrier frequency has to be in the middle. So from here to here is 50, and from here to here is 50. So in this case, this one has to be 150 kilohertz. 250, I'm sorry, okay. 250, because yeah, here you 50 yes, 50 250. So if you want to set in this band, so it has to be 250K. So this is the first question. The second question here, I'm asking about what is the bit rate given D. I give you D, and I ask you what is the bit rate, what is N. So as I told you here, the bit rate is actually 1 plus D times S, and I told you S is N. So here I give you D is 1. D is 1. So it's going to be 2 times S here. S is actually N times 1 over R, and R is 1, as I told you. So it's actually 2 times N. Okay. So 2 times N should give you the bandwidth, which is 100K. Okay. So that means the bit rate is going to be 50, half of the bandwidth in this case. In kilobit per second. Okay, so if I give you 100 kilohertz, that means I can transmit with 50 kilobit per second. Given G is 1, this is in case of G is 1. Any questions? So one important thing in this formula as well, so this formula is telling me is actually the bandwidth is equal to 1 plus D times N, because I told you S is N times N. So what this formula is telling me is if you need more bit rate, you have to ask for more bandwidth. What I'm saying? The higher the bit rate, if you need more bit rate, you have to ask for more bandwidth. Let me see it in a different way. If I give you a certain bandwidth, so this is going to restrict your bit rate. So if I tell you this is your bandwidth, that means your bit rate should be half of this value given if N is 1 from this formula. You got what I'm saying? So given your bandwidth, if I give you a certain bandwidth, so I'm gonna using this formula, N, this is the maximum bit rate you can transmit, is the bandwidth given to you divided by 1 plus D. Okay? In order to make sure you are not going to leave this area, in order to make sure you are going to continue on your bandwidth. What is that? D is constant. It's constant value. It depends on the quality of the filters and media is given to you. It's a constant value. In order to get it in reality, you have to do experiment and things like that. So it's a constant value. So it's anything you should not guess what is it's given to you. It's a constant value. But for sure, we can do something about it. You remember also in last chapter we had something constant value. It's called C, and most of the time we used to have for C. But you remember I came at the end of the chapter. I told you now because we did error correction, because we have 4 wires, because they were able to reduce C from half to 1/3. Okay. So anyway, it's a constant value. You don't need to worry about how it's calculated. So here it's going to be given to you. Okay, but at least for the same G, if you need more bit rate, so you need to ask for more bandwidth. Or in other words, for a certain bandwidth that is given to you, you can get a certain bit rate. You got what I'm saying? So if I give, for example, this is exactly here in this example. So in this example here, so I can do it either way. So here I give you the bandwidth. This is your bandwidth, okay? So out of this bandwidth, you can only transmit 50 kbit per second. You got what I'm saying? I can just do a minor change in this question, okay? what I can do here, I'm not gonna give you the bandwidth. I'm gonna ask you, I wanna transmit, for example, a bit rate, for example, of 75, for example, a bit per second. How much bandwidth do you need? It's exactly the same thing, but instead of giving you this one and make this one unknown, I just switched it. So this is, I'm gonna give you this one, and this one is unknown. So anyway, very simple. So actually, this formula gives you a relation between bandwidth and bit rate. Is that okay? Any questions? Okay. So now, you know, we have full duplex, and we have half duplex and full duplex. You understand the meaning? You know the difference. In case of half duplex, if you can either transmit or receive. So only one of us has to use the channel. Okay, you can transmit, and then when you are done, I can transmit. But we cannot transmit at the same time. Both of us cannot transmit at the same time. This is in case of half duplex. But in case full duplex, actually you can transmit and receive at the same time. How can we do that? Very simple. Yeah, very simple, because based on what I taught, we actually have here bands. That's it, bands. So you can take one band, and then I can take another band. So you can transmit through this band, and I can transmit through this band. So you can transmit at the same time. That's exactly what I'm explaining here. So what I'm explaining here is, as you see in this figure, I can take 50 kilohertz, and then you can take 50 kilohertz, and then you have to make sure your transmissions have to be here, and my transmission have to be in this range. How I can make sure of that? The signal you are going to modify, you have to make sure it is here. It is the signal you are going to transmit. It is going to be in the middle. Also, you have to make sure you are not going to exceed the bit rate given to you based on this bandwidth. So here's the bandwidth. This bandwidth should equal, for example, 1 plus d n, right? Or n should equal b divided by 1 plus d. Assuming, for example, d is 1 or whatever, so now it's going to be b divided by 2, okay? So that means if I give you 50k hertz, in order to make sure you are not going to get out of your band, you have to keep your bit rate no more than 25 kbit per second. Any questions? Okay. One more thing I can see here before I move to the next topic. Now, can I extend this idea? So now I explained here only 2 levels, right? One or 0, 2 levels. Okay. Can I extend this idea to have multiple levels, like what I explained before? Okay. For example, if I have 2 levels, as I explained before, let me put here one slide. Okay. So, for example, if I make L is equal to 4, okay. So as I told you before, if you have 4 levels, four voltage levels, for example, +1, -1, +3, -3, any numbers, but you have 4 different levels. So in this case, how many bits you can transmit, okay, in every signal element, or in every time slot, how many bits you can transmit is actually log2 of L, which is equal to 2 bits. So if I have 4 levels, I can transmit 2 bits. By the way, in the quiz, many students, when I give you a signal, what I did, I give you a signal, okay? Let me remember how was the question, something like that, for example. I give you a certain signal. If you look at the question, this is 1 second, this is 1 second, and here I'm going to transmit 0, 0, I'm going to transmit 1, 1, 0, 1, 1, 0, okay? So I'm asking you, what is the bit rate here? Okay, many students used this formula. Many students used this formula. Okay, this formula has nothing to do with the bit rate. This formula gives a relation between the number of levels, voltage levels you have, and how many bits you can transmit in every signal element. Okay, so for example, here this is given 4 because I have 4 different voltages. Every time I can transmit 2 bits. This is not a bit rate. Bit rate means how many bits you transmit in 1 second. So actually, you don't need to use this formula in this case. All what you have to do, you just look at the figure. From here to is 1 second. You can see how many bits will transmit in the 1 second. That's it. Okay. For example, here we have 2, 2, 2, 2. So this example, I transmitted 8 bits in 1 second. So the bit rate is 8 bits per second. Okay. So in this case, when I give you a signal, this is exactly like when I give you a sine wave, and I ask you, what is the frequency? You have to look at this one. What is the period? You have to look at this one. It's exactly the same thing. The same thing here. Okay. So again, because I'm saying it because I found many students are confused between they don't well understand this formula. This formula gives you a relation between the voltage levels and the how many bits you can transmit in every, or in other words, if I want to transmit 3 bits, so how many voltage level I need? If I want to transmit 4 bits every signal element, how many levels I need? Relation between them. It has nothing to do with bit per second. How many bits you transmit in 1 second? Okay. No. This is number of bits. If I want to transmit 2 bits, so how many levels, voltage level I need? If I want to transmit, look here. If I want to transmit 1 bit every time 1 bit, how many voltage level I need? I need 2 in this case, because one level, I'm going to consider it 1. Another level, I'm going to consider it 0. Is that okay? I need only 2 levels. 1 for 1, 1 for 0. Is that okay? The other one, if I want to transmit 2 bits, so 2 bits, so you actually have 2 to the power 2 cases. 2 to the power 2, which are 4 cases. So I need 1 voltage for each case. I need 1 voltage for each case. You got what I'm saying? Same thing if I want to transmit 3 bits. So actually here I'm going to have 8 cases. So actually I need 8 levels, 8 voltage level, 1 voltage level for each case. Anyway, so let's return to my question here. So what I explained here, I explained in case if you want to transmit only 1 bit, you want to transmit 1 bit, one bit in every signal element. Very simple question. Can I extend this idea, the idea here I have just explained, so that I can transmit here 2 bits or transmit 3 bits here, 2 bits or 3 bits? Okay. So answer for sure, yes. For example, if you wanna transmit 2 bits, you have to make sure, if I want to transmit 2 bits here, so here you have to make sure you should have 4 different amplitudes. You got what I'm saying? For example, I'm going to use 0 amplitudes, for example, for 0, 0, and then I'm going to have a certain, I'm not going to change frequency or phase. I'm going to only have 4 different amplitudes. For example, I'm going to have this amplitude, okay? For this is when you see this amplitude, this should be for example, for 0, 1, just an example. And then I can have another signal with another amplitude this way, and then I'm going to use this one for 1, 1 or 1, 0, whatever. Okay, and then I'm going to have another. So the circuit you should have here for this circuit, you should have. I'm going to have another amplitude. So instead of having 2 amplitudes, okay, as we did here we had 2 amplitudes. 1 amplitude here for 1 for 1, 1 for 1, and 1 for 0. But here I'm going to have 4 different amplitudes. Is that okay? Yes, we can for sure, but you have make sure. Okay. Anyway, so let's talk about what is good about this modulation, demodulation scheme. What's good and what is bad. What is good? Number 1, it is simple. As you see, it is just the implementation is just very simple. Okay, and also the bandwidth is good comparing to what we are going to see later. This good bandwidth. It's a simple and the bandwidth is good. This is a good thing. What is the bad thing about this one? Is the noise. The noise has a bad impact on this one. Why? Because as I explained before, what the noise is going to do? The noise is going to change the voltage. It's going to change the voltage. So maybe if this one, if the noise reduce the voltage to here, instead of receiving this 1, 1, 0, I'm going to receive 0, 1. You got what I'm saying? So this is the good thing about this one. The noise attenuation the channel impairment have a big impact on the signal. Okay, this is, you will see right now, this would be much better than the other two cases, frequency and phase shift. Why? Because the noise has less impact on the frequency than the amplitude. You got what I'm saying? So the noise has big impact on the amplitude, but the noise has less impact on the phase or frequency. Is that okay? Let me see. I have some difficulty to log into the Blackboard. Let me see if I will try again. Well, for some reason, I'm not receiving the code. So do you have, can anybody have like one piece of paper and just write your names? Okay.
Regarding this,
No. No, I think it's almost one chapter, because the other chapter has small part. For chapter what? الباقي 50 slides. But no, I think impairment chapter, yeah, chapter 3 here. No, it's chapter, it's, you mean chapter 3, it's a whole chapter, right? But chapter 2, it's no, but it's not 50. It's not 50. It's, this is the easy part, is the impairment part, impairment, and also data rate limits.
Hearing this information is just, and have that easy and this we're getting, you know, you think I'm just yet.
The second one is frequency shift keying. Okay. Can you have a piece of paper and write your names quickly, please? Because I don't. Okay, make it one chapter. That's okay. Are you happy now? Okay. It's gonna be chapter 3. No, not 2. Is that okay, or you want a 2? Anyway, so let's because we still have 2 minutes here, so let's talk about frequency shift keying. Okay. So the idea, why you are laughing? So let's do it 3 and 2. Okay. I changed my mind. Make it 3 and 2. Anyway, the second one is frequency shift keying. Okay. So as I told you before, it's exactly the same concept, the same idea. We have 0 and 1, but this time it's the same idea, but this time I'm not going to change the amplitude. I'm going to change the frequency. So what happens here, I'm going to have a certain one frequency for 0. I have another frequency for 1. So I'm going to have 2 different frequencies. One frequency for 0, one frequency for 1. Okay, I'm going to change the frequency instead of the amplitude. And as I told you, these two actually, the frequency and amplitude, is much better than the frequency and phase. These two are much better than the amplitude because of the impact of the noise. The noise has bigger impact on this one than the other ones here. Okay, so as you see here in this figure, we have here, what we have here is, for 1, we're going to have a certain frequency. I'm going to call it F1. For 0, I'm going to have another frequency. I'm going to call it F2, as you see here. So here, every time I want to transmit 1, so I'm going to transmit a sine wave with frequency F1. Every time I want to transmit 0, I'm going to transmit a sine wave frequency F2, as you see here. So you can see just a sine waves with different frequencies. At the receiver side has to keep track, or has to measure the frequency here. If it is F1, so it's going to take it like 1. If it is F2, it's going to take it like 0. Okay. So now let's talk about what is the bandwidth we have here, okay? Because of the way we did the signal this way, the bandwidth is gonna look like something like that, okay? So it's gonna look like we have F1, okay? And some frequencies around F1, and we have also F2 and some frequencies around F2. So this is the band. So the bandwidth I am gonna use here is actually from here to here. This is the bandwidth. Is that okay? So I have to make sure I have enough bandwidth to cover F1 and F2 this way, okay? So let's see. So how big is this one here, okay? Let's start with R. What is R? Yeah, R is still 1, right? Because if you see here, every signal element will transmit only 1 bit. So R is still 1, okay? What is S? S actually is equal to N times 1 over R. So S here is N, similar to what we did before. So if you see here, everyone here is gonna be S or N times 1 plus D. It's the same thing here, S or N times 1 plus D. Okay. So what is, you can quickly tell here, what is bad here comparing to what I explained to you before. What is bad is the bandwidth is double, because if I go back, you will find only one. This was one of them was only the bandwidth before. So here you can see the bandwidth here was actually 1 plus D times N. This is the bandwidth. Now the bandwidth is going to be double, which is bad for sure. So again, so here in frequency shift keying, yes, this one is more resistant to noise. This is a good thing. It's more resistant, but I paid the heavy cost for that. The heavy cost I paid double the bandwidth as you see here. Is that okay? So, okay, I think that's enough. I can continue next time.